Hello everyone. Let's begin with an interesting thought. Have you ever wondered why an apple falls straight down from a tree and not sideways? Or why when you drop your pen, it always heads towards the ground? This is because Earth constantly pulls every object towards its center with a force called gravity. From your earlier lessons, you already know the three basic kinematic equations of uniformly accelerated motion. They are equation 1, v equals u plus a t, equation 2, s equals ut plus 1 by 2 a t squared. Equation 3, v squared equals u squared plus 2 a s. Now, when motion takes place under gravity, we make a small change. We replace acceleration a with g, the acceleration due to gravity, and we replace displacement s with h, which represents vertical height. In this way, the same set of equations beautifully describes the motion of bodies falling freely under gravity or moving vertically upwards. For example, when you drop a ball from a height, these equations directly predict its velocity and displacement at any instant. Let's move to the first equation. Under gravity, the relation is written as v equals u plus gt. Here, v is the final velocity after time t, u is the initial velocity at the beginning of the motion, and g is the acceleration due to gravity. Suppose a ball is dropped from rest, which means u equals 0. After 3 seconds, its velocity becomes v equals 0 plus 9.8 into 3, that is 29.4 meters per second. This simple relation tells us how quickly the speed increases as the object continues to fall. Notice in the velocity time graph, the straight line shows velocity rising steadily with time because of constant acceleration g. Now let's look at displacement. The second equation under gravity is h equals ut plus 1 by 2 gt squared. This gives the vertical distance traveled in time t. The term ut accounts for the motion due to initial velocity, while the term 1 by 2 gt squared shows the additional distance gained due to gravity. For instance, if a stone is dropped with 0 initial velocity, then in 2 seconds it falls a distance equal to 1 by 2 into 9.8 into 2 squared, which is 19.6 meters. You can also understand this from the velocity time graph where the area under the curve represents displacement. The third equation is especially useful when we don't know the time. It is given as v squared equals u squared plus 2gh. It relates final velocity directly with initial velocity, gravity, and height traveled. Suppose we drop a body from rest, so u equals 0, and it falls through 20 meters. Then v squared equals to into 9.8 into 20, which comes out to 392. Taking a square root, v equals about 19.8 meters per second. This shows that the velocity depends only on the vertical distance traveled, not directly on the time taken. Now, what happens if we throw an object vertically upward? In that case, gravity acts opposite to the direction of motion, so we take acceleration as minus g. At the highest point, the velocity becomes 0. From the third equation, we can calculate maximum height reached, h equals u squared divided by 2g. Similarly, the time to rise is given by t equals u divided by g. For example, if a ball is thrown upwards with 20 meters per second, the maximum height is 20 squared divided by 2 into 9.8, which is around 20.4 meters. The ball first slows down, stops for an instant at the top, and then falls back with increasing speed. The diagram here shows the complete rise and fall path under gravity. To close this discussion, let's recall the assumptions. First, the height reached by the body should be small compared to Earth's radius so that g remains constant. Second, we assume that air resistance is negligible. Under these conditions, the equations of motion under gravity hold true. So, let's quickly revise. Equation 1, V equals U plus GT. Equation 2, H equals UT plus 1 by 2 GT squared. Equation 3, V squared equals U squared plus 2 GH. These relations help us explain so many real-life situations, from the free fall of objects to the vertical throw of balls to the design of parachutes and rockets. I hope you now clearly understand how gravity shapes motion in our everyday world. See you in the next session, where we will explore another fascinating concept of physics.